Hello and welcome to my channel. In this video, I'll be covering Tideman from CS50's problem set 3. So how is this program gonna work? This program is gonna be implementing a voting algorithm called Tideman, and so users or voters can vote for their preferred candidates in a rank fashion. So the voters first rank, second rank, third rank, and so on. And how we are gonna determine the winner of this election is gonna be using a system of margin of victory. The candidates will be battling against each other on a head-to-head matchup in a sense. So for example, Alice is gonna compete against Bob, then Bob is gonna compete against Charlie is gonna compete against Alice, and so on, right? And then depending on which competition has the highest margin of victory, we'll be adding an arrow, okay, an arrow from one candidate to another. So in this scenario, we see that the margin of victory between Alice and Bob is the greatest, which is 7-2. So Alice won over Bob by 7 votes and Bob won over Alice by 2 votes. So we point Alice to Bob, okay, and then afterwards we have Charlie to Alice. So Charlie is preferred over Alice by a margin of 6-1. And then lastly, we have Bob, which is preferred over Charlie by a margin of 5-4. But we won't be adding this arrow, because if we add this last arrow, it's gonna be creating a cycle, which we do not want. Okay, so this is technically how the program is gonna work. And as we go along coding and solving this problem set, you guys will be able to understand how I implement the various functions that we have to implement. And most of you guys probably came here for the log pairs function, right? Yeah, don't worry, I'll be explaining each of the functions and how I implement them in detail. So now let's get started. Alright, so here's the code. We have some includes and we have to add more includes in just a bit. And then here's the maximum number of candidates that our program can handle. Preferences array, that is gonna be storing the number of voters that preferred candidate I over candidate J. Locked, which is gonna be storing the arrows in our graph. And then here we have a structure of pairs. Each pair is gonna have a winner and loser. And then we have a string of candidates, which is going to be storing the names of the candidates. Then we have an array of pairs, which we'll have to sort, determining based on the strength, right? So here we have to do sort pairs, and we have to sort the pairs array in decreasing order of strength of victory. Okay, and then pair count, candidate count, this is going to be helping us with some of our calculations. And then we have our function prototypes. These are the functions that we have to fill up. And then we have the main function, and they have implemented some of the logic for us already. So for example, the user has to add function arguments for the name of the candidate, and also the users can only add a maximum of 9 candidates. And here we are going to be storing the name of the candidates, and then here we are resetting the locked array so that all of them is false, so there is no arrows pointing at anyone, okay? And then we are setting the number of pairs to be 0, and then next we are getting the number of voters from the user. And next we are going to be querying for the voters. So here we will be asking for the name of for example 5 voters, right? If we are using this example, number of voters 5. And now moving on to our very first function. So what our very first function vote is going to be doing is it's going to be updating the ranks array, right? Updating the ranks array. And what else it's supposed to do is to check if the candidate's name is valid. So let's implement the vote function, and now to check if the name of the candidates is correct, we want to be iterating through all of the candidate names, and to check if the name is correct, we can use sure compare. So for int I equals to 0, I less than candidate count, I plus plus, and let's iterate through all of the candidates. So if stir compare name that is entered by the user and candidates I is equals to 0, then we can just return true, right? Because the user has entered correct name, and we don't have to do any checks. But before entering true, we want to update the ranks array, right? So we passed in this ranks array so that we can update the ranks. So ranks rank. So we're updating the ranks array for the rank given by the user. So for example, the first rank, second rank, third rank, and so on. So rank is going to be equal to the index of the candidate. Yeah, okay, so that's that. I think our vote function is done, but just to double check, because Tideman is a pretty tedious programming problem set, so I'll be checking if we are doing everything right after completing each function, because I don't want to go back and try to debug what went wrong. So let me just run check 50. So make Tideman, hopefully nothing wrong. Okay, so compare. Yep, I forgot to add include ctype.h. What did I do wrong? Okay, it's not ctype, it's string.h. But you know what, I was just gonna be leaving that in as well. Okay, string.h, make Tideman candidates. What did I do wrong? Okay, my bad. Yeah, that's something wrong with like where I positioned my brackets. My bad. Make Tideman. Okay, correct. So let me just do a check 50 to just check if everything is right. Okay, so the vote function is working as expected. Now moving on to the next few functions. So the next function we have to complete is the record preferences function. What this function is gonna do is to update the preferences array. Okay, so we have the preferences array here, and we want to update the preferences array such that it's gonna be storing the number of voters who voted who preferred candidate I over candidate J. So how is this algorithm gonna work? It was already discussed in the walkthrough, and we'll just be following the technique that they taught us. So if you guys noticed here, and I'll also be explaining how to do it on my iPad as well. So but before that, you guys understood what they mentioned here. You'll notice that candidate 3 is preferred over candidate 0, 4, 1, and 2. So preferences 3 to 0 is gonna be added by 1, 3 to 4 is gonna be added by 1, 3 to 1 is gonna be added by 1, and 3 to 2 is gonna be added by 1. If you guys don't get it, don't worry. Let's go over to my iPad. So let's use the example that they gave us, right? Let me change the color. Okay, so we have 3, 0, 4, 1, and 2. And so preferences 3 and 0 is going to be added by 1, and 3 and 4 is going to be added by 1, 4 and 1 is going to be added by 1, 4 and 3 and 2 is going to be added by 1, because candidate 3 is preferred over all of this. And then next, we are done with 3, we can move over to 0, right? So 0 was preferred over 4, 0 is preferred over 1, 0 is preferred over 2. So if you guys notice, what we're doing is actually so what we want to implement can be implemented using the nested for loop. So first, this is the outer for loop, and then we loop through everything after it, and then there's the outer for loop, and then we loop through everything after it, and so on. If you guys don't get it, don't worry, just take some time to try to follow along how the code is working. So let's type in the code. Record preferences. So for int I equals to 0, I less than candidate count, I plus plus, and then next we want an inner for loop as well. So int j equals to 0, j less than candidate count, j plus plus, and we have to modify our for loop in a way because we want to start our outer for loop from 0, yes, but our inner for loop we want to start from I plus 1. We want to start we want to start comparing from after it. So 3 is compared to 0, which is after our current I, right? And then we want to end comparing before we reach the end, okay, so that we can still plus 1 to it. Okay, so now yeah, let's do this part. So preferences preferences rank I, okay, and then preference rank I compared to rank j is gonna be added by 1. So one candidate preferred 3 over 0, one candidate preferred 3 over 4, and so on. So this should be it actually for the record preferences. And let's just check using CS50, make Tideman. What did we get wrong? Ranks, okay. Make Tideman, okay. Let's do a quick CS50 just to check if our function is correct. So as we can see here, our record preferences was done correctly. So now moving on to add pairs. So what we're gonna do in add pairs, we will be comparing the number of votes that a certain candidate have over a certain candidate, and then see if there is a margin of victory. Okay, like for example, Alice is preferred over Bob by a margin of 7-2, and if there is a margin, we'll be adding it into the pairs array, and we'll be adding in who's the winner and the loser of the pair, because we have a pair struct. How we'll be doing it is by using nested for loop. Okay, so in the walkthrough they also went through this portion as well. So add pairs, right? We have the preferences, and we'll just be iterating through using a nested for loop. So let's do this portion, and once I add in the code and explain the code, you guys should be able to understand how to do this part. So for int I equals to 0, I less than candidate count, I plus plus, and then we have another for loop for int j equals to 0, j less than candidate count, j plus plus. And once again, we want our j to be I plus 1, and we want our I to end before the last candidate. And what we'll be doing here is comparing if there's a winner and a loser to the pair. Okay, so preferences I over preferences j minus preferences j over the preference of I. Okay, and this is gonna determine the strength of victory. Okay, so let's create a variable. So int strength. Okay, so strength is gonna be this minus this. Why we're doing this is because we want to see if one of the candidates is preferred over the other. because if one of the candidate is not preferred over the other, we do not want to add it into the pairs array. So after we determine the strength, okay, we can see if the strength is a positive number or a negative number. If it is a positive number, then we know that I 1 over j, and if it's a negative number, we know that j 1 over I. So that's how we can add it to the pairs array and the pairs struct, because in the pairs struct we have to tell the struct who's the winner and who's the loser. So if let's see if we can use one of the functions that they have provided for us. We don't have to actually, it's alright. So if the strength is more than 0, okay, then we know that I is the winner and j is the loser. So what we can do is pairs pair count, is that what it's called? Yeah, it's called pair count. So I pair count dot winner is equals to I, okay, and pairs pair count dot loser is gonna be j, okay, and then we want to add our pair count at the very end, just to signify that we have an extra pair, okay. So else if strength is less than 0, then we know that pairs pair, let me just copy and paste this. So the winner is j in this scenario and the loser is I in this scenario, and in the very end we still do a pair count plus plus. Okay, so that should be it actually. Let me just see if I'm missing anything out. Okay, let me just make Tideman and let me just run a check to check if our add pairs function is correct. Okay, nice, our add pairs function is correct. Now moving on to sort pairs. So sort pairs, you can use a variety of sorting algorithms, but what I was comfortable with was selection sort. Okay, so what I'm gonna do is let's hop over to my iPad again. So what I'm gonna do is so we have a number of pairs, right? We want to be sorting the pairs in strength of victory. So whoever has the strongest pair, we want to add it to the front, and then the weakest pair is gonna be all the way at the end. So what we're doing is we set this as the strongest pair, and then we compare it to the others after it, and then we will determine which is actually the strongest. For example, we find out that this is in fact the strongest, and what we'll be doing is swapping these two, okay, and it's basically selection sort. While I'm writing the code, it should be making much more sense to you guys. So let's do that. So for selection sort, we have to do nested for loop. So for int I equals to 0, I less than candidate count, sorry, I less than pair count. So since we are doing a selection sort on the pairs, we have to do pair count I plus plus, and then a nested for loop, which is going to be int j equals to I plus 1, okay, j less than pair count j plus plus, and once again we want to minus 1 to this because we don't want to be adding 1 after I is already like at the end. Okay, so here at the very beginning, the strongest, so int strongest is gonna be the current pair. So how we find the strength of victory is gonna be preferences pairs I dot winner and compare it to the pairs I dot loser, okay, and minus the opposite of that, which is gonna be I dot loser compared to I dot winner. Okay, this is gonna be helping us find the strength of victory. So for example, in the example that they gave us, let's say it's Alice versus Bob. What's gonna happen is the preferences of Alice over Bob is gonna be 7, and the preferences of Bob over Alice here is gonna be 2, and the strength of victory, the difference, is gonna be 5. 7 minus 2 is 5, and so the strongest one is gonna be at the very front, and the weakest one is gonna be at the very end. So now we want to calculate the current strongest strength. So int current strongest, and I won't be initializing it. So current strongest is gonna be equals to something like this, but for J, okay, and then we want to compare the initial strongest to the current strongest and determine what is actually in fact the strongest. So if the strongest is not as strong as the current one, then we want the strongest to be equals to the current strongest. Okay, and apart from that, what we also want to be doing is storing what is the index, the pair index from the pairs array, which is the strongest. So it's going to be we need to have another variable which is going to be strongest index. So int strongest index, initially the strongest index is going to be I, okay, but slowly once we find out that, oh, actually I is in fact not the strongest, what we want to be doing is strongest index equals to J. Okay, so now after doing that, after finding out what is in fact the strongest index and also the strongest margin of victory, we want to be doing the swap, right? Because it's selection sort, and so that is all the way at the end of the inner for loop. And here what we'll be doing is if the strongest index is not I, then we want to do the swap. So pairs I equals to, pair buffer is gonna be equals to pairs I, okay, and pairs I is gonna be equals to pairs strongest index, and then pairs strongest index is gonna be equals to buffer. Okay, so this is just swapping between pairs I and pairs strongest index. Okay, so that should be it actually. I don't know why this is not color coded. I think I might have, oh yeah, missing semicolons. So this is one benefit of doing using VS Code in dark mode. You can like see it, everything better. Okay, so I think that's it for the sort pairs. It should be correct, so let me just check with check 50. Alright, so it got correct. Alright, so now moving on to log pairs. So this is probably the function that most of you guys are here for, and I'll be going through with you guys the thought process that I came up with to figure this function out. And to be honest with you guys, it was pretty difficult, but after much thinking and some help here and there, because I've done this question before, but even still, like recursion and coming up with like the algorithm of like how to figure it out is pretty difficult. So let's attempt this function, right? So log pairs. So the function should create a locked graph, adding all edges in decreasing order of victory strength, so as long as the edge would not create a cycle. So let's say, so I mean before that, we will have to be looping through our pairs array, right? So for int I equals to 0, I less than pairs count I plus plus, and then if there isn't a cycle, then we want to log the graph. So if not a cycle, then we want to create a graph, which is gonna be locked pairs I dot winner pairs I dot loser, right? So that should be it actually, but then of course we have to figure this cycle function. Sorry, this one we have to make it true, so we lock the pair. Else, if it is a cycle, then we don't want to lock the pair. So now let's try to figure out how we are gonna be implementing the catch to see if it's gonna create a cycle. And for this, let's take some time to figure out this algorithm. So if you guys take a look at my iPad, we have for example Alice, Bob, Charlie, and David. So when we want to point from Alice to Bob, we know that it's not going to be creating a cycle, because simply put, Bob is not pointing towards anyone. Okay, so if Bob was pointing towards anyone, then we could have gone on with figuring out what's going on. So no issues with that, all's good. Let's say Bob is pointing towards Charlie. Is there going to be a loop? No, because Charlie is not pointing towards anyone. If Charlie is pointing towards David, is there going to be a loop? No, not really, because David is not going to be pointing towards anyone. How about if we want to point David to Alice? Well, there is going to be a loop, but in fact, the computer will not be able to see quite a few bit of information. The computer will not be able to see this here. So what we have to tell the computer is that, you know, if we want to point towards someone, please check who, let me just change the color. If we want to point towards someone, so let's say David pointing towards Alice, we want to make sure that, you know, whoever Alice is pointing to and whoever is pointing towards that and whoever pointing towards that doesn't end up with David. So we need some variables to keep track of that. So now going back to that, we want David to be our winner, right? David is our winner and Alice is our loser. Hence we want to point from Alice to David. And so in our function, the winner is gonna be David and the loser is gonna be Alice. But we want to check who is Alice pointing towards. So, and then we use our calculation, and this is not very difficult. We can just check through the log pairs, and we notice that Alice is pointing towards Bob. So what we can do is, instead of the loser being Alice, the loser can be Bob instead. Okay, so now the loser is gonna be Bob. And then we see that, oh, actually Bob is pointing towards Charlie. Okay, so now the loser is Charlie. And then we notice that actually Charlie is pointing towards David. And then what happens is very interesting. David becomes the loser. And then what do we notice? The winner and loser is both the same. Okay, so this is gonna be the catch that we'll be using, okay, in our recursion. Basically I forgot what's the term used for it, but oh yeah, the base case. So this is gonna be the base case. So if L is equal to W, then we know that it is in fact a cycle. Okay, so let's implement this cycle code. Okay, so not cycle is gonna have an input for winner, so int winner and int loser. Okay, and it's gonna be returning a boolean to signify if there is a cycle or there isn't a cycle. And we want to create a function prototype for it. So boolean not cycle, and the input is int cycle and int loser. Okay, so now in our not cycle we want to pass in the winner and the loser, which is gonna be pair I dot winner comma pairs I dot loser. Okay, and then what we want to do here is of course the base case, which is gonna be if loser is equals to winner, then we want to return true. Actually, boolean cycle, so to check if there is a cycle. Okay, I'm gonna change the top as well. So boolean cycle, so if there is no cycle, so false, then we want to do it. So if there is a cycle, then we want to return true, that oh okay, there is a cycle, please signify to the main program that there is a cycle. And then of course this is only if the loser is equals to winner. We also want to have the case that, you know, we want the program to see if the loser is winning anyone. So how we will be doing it is for int I equals to 0, I less than pairs count, candidate count, actually candidate count I plus plus. And then what we want to do is figure out if for example in this scenario when we want to point, let me change the color, when we want to point from David to Alice, David is the winner and Alice is the loser. So let's see if Alice is pointing towards anyone. So if locked Alice, which is gonna be the loser, is pointing towards anyone. Okay, if this comes up to true, then what we want to do is run the cycle function again, but this time telling them that you know, the winner is still David, but the loser in this scenario is gonna be I. Okay, because now for example initially the winner and loser is David is the winner, then Alice is the loser. Now after the second iteration, the loser becomes Bob, and then the loser becomes Charlie, and then the loser becomes David, and then the winner and loser is both Charlie and David. If you guys don't get it, take some time to you know, follow through the code, try with your own examples, and sooner or later you'll be able to get it. And don't worry, for recursion, right, you guys need practice makes perfect. And so do some recursion practices online, you guys can find some, and sooner or later you get a hang of it. And plus Recursion isn't even that important, as of now at least. Don't worry, you guys get a hang of it sooner or later. So that's that. And so what we want to do here is, if the cycle winner comma I equals to true, then we know that there is a loop, then we want to return true. If there isn't, we'll let the loop continue all the way to the end, and in the very end we know that, oh, there isn't a cycle, so we can just return a false. And that's the end of our program. And let's just make sure our log pairs is correct. So we are checking if there is a cycle. If there is no cycle, okay, then we want to add in to our log pairs, and that's about it. Okay, let's try and make Tideman pair count line 188. My bad, pair count. Once again, let's try and make Tideman. If my bad, it's supposed to be equal true. / Tideman. Okay, let's do the check 50 just to check if our log pairs is working fine. I have a bad feeling about this, but let's just see. Okay, wow, alhamdulillah, log pairs is fine. You know, I'm actually so pleasantly surprised that I didn't have so much issues with Tideman, because it's a very tedious program, and like all of them seems to have worked on my first try, relatively. Technically not first try, but technically first try as well. Alright, so lastly we have the print winner function. Finally we have come to almost the end of Tideman. So let's do the print winner function. So the print winner function, right, if you guys take a look at the walkthrough video, the winner will have no arrows pointing towards them. Okay, so as you guys noticed, there is no arrows pointing towards Charlie in this example that they showed us. So in our scenario as well, the winner will not have any arrows pointing towards him. And if you guys noticed, in the table that they showed, at the very last column there, it's all false because there isn't anyone pointing towards Charlie. So that's the technique we're gonna use as well. So we'll be determining if all the entire column is false, and if it is, then we know that that person is the winner. So for int I equals 0, I less than candidate count I plus plus. And for this we need a nested for loop for int j equals to 0, j less than candidate count j plus plus. So now what we want to do is check which column is all false. So how we're gonna do it is locked j I if locked ji is equals to true. So if the column ever shows true, then we know that this is in fact not the answer, and we'll be breaking out of the for loop and going on to the next column. However, if it is the correct answer, then what we'll be doing is printf %s \n comma candidates I. Okay, let me just double check. Candidates, yes, candidates I. This should be correct actually. Sorry, no, this is not correct. Yeah, okay. So what we have to do as well is to store, use a variable to store if someone has a true with them. So initially we set this variable, so bool is winner to true. So initially it's a winner, but then if they have a true with them, the is winner is gonna be false. But then at the very end, if is winner is retains its true status, then we want to print the user as the winner. Okay, so now this should work, and let's run make Tideman and semicolons make Tideman. Okay, now let's run check 50 once again, and hopefully this is correct. Alright, so that's the end of Tideman. We managed to get it all correct. If you guys enjoyed this video, please hit the like button and subscribe. If you guys have any questions, comment down below and I'll try my best to help you guys out. And see you guys on the next video. Bye bye.